Let's talk about Venn diagrams, which is a great way to organize information. We especially use these in probability problems. At a certain store with 50 employees, 20 worked on Black Friday, 15 worked on Christmas Eve, and 8 worked on both dates. Okay, let's draw a Venn diagram. So a Venn diagram is usually just circles that overlap. Okay, and I'm going to write this one. This circle represents Black Friday. This circle represents Christmas Eve. So first of all, we had 8 people that worked both. So we're going to put them in the middle. Now, 20 worked on Black Friday. But the thing we have to be careful here is that that is the total number of people that worked. And we've already counted 8 of them who worked both. So in this part of the circle, I'm going to write 12. Because if 20 total worked Black Friday, but 8 of those also worked Christmas Eve, then 12 must have worked Black Friday alone. So doing the same type of thing for Christmas Eve, we must have 7 people that worked only on Christmas Eve that gave us a total of 15 people. Now, if you add up those numbers, you say, okay, 12 plus 8 is 20, plus 7 is 27. I often like to then say we had 50 employees and we've accounted for 27. That means there are 23 people that are just kind of out here because they didn't work either one of those. All right, let's work some probability. All right, so what is the probability that a randomly selected employee worked only on Black Friday? Well, remember, probability is always the number of people we're kind of looking for, the number of situations that we're looking for out of the total. Well, we have 12 people that only work Black Friday out of 50 total employees. And you could reduce this, to be 6 over 25, or you could, calculate that is 0.24. Only Christmas Eve. Well, this is the 7 out of 50, or 0.14 if you prefer decimals. Now, at least one of the 2 dates, so at least one means it could have been either date, or it could have been both. So we want to say, well, we had 12 Black Friday only, we had 8 both, we had 7 Christmas Eve, all out of 50, and that is 27 out of 50. If we prefer a decimal, we'll write 0.54. Neither of those dates. Well, again, we already figured out that 27 people worked at least one of those dates, so the other 23 didn't work any of them. 23 out of 50, or 0.46. So again, it's just a way of organizing information that can make it a little bit easier to grab the numbers. Let's do a little more complicated one. Looking at a little bit more complicated Venn diagram, let's say in a certain community we have 3 different summer rec league sports offered for first and second graders: soccer, swimming lessons, and t-ball. Let's say there are 210 students in first and second grade. 120 play t-ball, 50 play soccer, 60 sign up for the swim lessons. So we have 3 things going on, and I'm going to draw 3 circles. So we're going to have a t-ball. We're going to have a soccer, and we're going to have a swim circle. Okay. Now, I'm going to start kind of reading the whole thing before I write anything down. We've got 120 that play t-ball. We've got 50 that play soccer, 60 sign up for swim. 20 play t-ball and soccer. So I'm going to put that number right in here. We've got 20 in this overlap. And then it says 15 play soccer and swim. So I'm going to put 15 right here in this overlap. 10 sign up for t-ball and swim. So I'm going to put 10 right here. And then 5 sign up for all of them, like this. Okay, I always like to do the overlaps first. It helps me kind of fill in the rest. Now, one thing I just want to mention here is we were told 120 play t-ball. Just overall, 120 play t-ball. And you'll notice that, we have 20 here, 5 more, 10 more. So right here, we've got 35 kids already accounted for that play t-ball. So we could just say, all right, 85 then must have played t-ball and nothing else. Sometimes there are questions that will actually word it that way, and instead of wording it this way, they would say 85 play only T-ball, and that actually makes an easier question, okay? But, so you just got to read carefully. We weren't told 85 play only, we were just said overall 120, and that's going to be the same for the rest of these as well. So you see, 50 play soccer. It doesn't say 50 play only soccer because that way we put the 50 right here without an overlap. But this said 50, so we'd say, well, this is 20 plus 20 more. So we've already accounted for 40 soccer players, which means there are only 10 left that play only soccer. And finally, 60 sign up for swimming. Well, we got 20 here, 10 more here, right? So 30. So we only have 30 left over that only swim. Now, one thing you might be asked to do is you might be asked to convert these to probabilities, each of these things. And the thing to remember is we had 210 students. So if someone said to you, well, what's the probability you only play T-ball? You'd say, well, 85 out of 210 is only T-ball. What's the probability you only played soccer? Well, 10 out of 210. Only swimming would be 30 out of the 210. And you could also do these in these overlaps. I just didn't leave myself enough room. But if someone said, well, what's the probability they signed up for all three? You'd say, well, 5 out of the 210. Okay? So this is the way to make these. And then, of course, you could answer the questions. What's the probability someone only played T-ball? 85 out of 210. What's the probability they didn't play T-ball at all? Well, you could, subtract out the 120 that played T-ball from 210 and do that. So there are a lot of questions you could ask here. The difficult part was just kind of drawing the Venn diagram. Let's talk just a couple more things. Venn diagrams give us a nice visual way to talk about the terms mutually exclusive. And mutually exclusive means two events that cannot occur at the same time. And why I said the Venn gives a nice visual is it would be two events that look like this. It would be impossible to have an overlap. One easy example would be, let's say you pick a random student at school. What is the probability they're in Algebra 2 and geometry? Well, you can't be in both at the same time because you have Algebra 2 students, you've got geometry students, but in order to take Algebra 2, you have to have passed geometry. So you can't be taking both at the same time. There's no overlap. There's no students in both. So we would say those events are mutually exclusive. And because there's no overlap, the probability of someone being in both at the same time is 0. Okay? So, you have a deck of cards and you pull one card. What's the probability it's a king and a 2? Well, 0. You can't get a king and a 2, right? Drawing one card. So it's two events that it's impossible for them to occur at the same time.